Hello, third year. So this is part B of your videos for this week. This is going to look at analysing standard deviation. So in the same way that we did last time with interquartile range, we worked out how to calculate it, and then we worked out how to analyse it, how to do these kind of things. We're going to do the same with standard deviation. So last video we looked at how to calculate standard deviation. This video we're going to look at how to analyze it, but we're also going to do a standard deviation calculation. I'm going to move through the standard deviation fairly quickly because that's not the main purpose of the video, and then I'm going to look at part B. So really question B here, is really what we want to focus on. Okay, this is a past paper level question. Okay, so I'm jumping into quite difficult. Well, it's not too difficult stuff, but these questions are very typical. Standard deviation questions tend to follow the same sort of format. Okay, so they're not too bad actually. They're quite processy. So anyway, let's have a look at this question and see how we get on. Okay, first things first. Question A says, so we've got Scott training at a velodrome on his new bike. He's recording top speed in kilometres per hour, and he's done 6 laps there, so that's the important stuff. And then we've been asked to calculate the mean and the standard deviation, so that's all fine. Okay. Quick check just to have a look at the data. Is it in numerical order? No, it's not. I prefer to work with the data in numerical order, so that is the first thing I'm going to do. So I'm going to do 58.3, then 59.1. Oh, mistake. We've got a 58.8 in there, so let's just do that first. 58.8, then 59.1, then 59.8. Let's just score those out and make sure that we're right. And then 60.4, and then 61.2 is the last piece of data. So that's us in numerical order now. Okay, next thing we want to do is calculate the mean. So x bar, remember that's just our shorthand for the mean. We're going to add up all these values. So we're going to add 58.3 plus 58.8 plus 59.1 plus 59.8 plus 60.4 plus 61.2, and we should get 357.6, and we divide that by the number of bits of data, which is 6. Now I'm just going to move this table down slightly out of my way. So 357.6 divided by 6, we're saying, x bar is 59.6, and that's in kilometres per hour, so kilometres per hour. Okay, so that is the mean calculated, job done. Okay, so that's part 1 done. The next bit of this is to calculate the standard deviation. Okay, now remember your standard deviation formula. This is given to you in the exam, but it is the square root of the sum of x minus x bar squared all over n minus 1. Okay, now this table hasn't extended the final column quite as much as I would have liked it to, but we'll not worry about that. Top of the column is x, then x minus x bar, then x minus x bar squared. Remember, whenever I say x bar, I'm talking about the mean. Okay, that's what I mean when I say that. Okay, so anyway, values into x here, so we put them in numerical order: 58.3, 58.8, 59.1, 59.8, 60.4, and 61.2. Now from each of those values of x, each of those values here, we are going to subtract the mean of 59.6. Okay, and that's what goes into this column here. So we take each of our data values and we subtract the mean. So 58.3 minus 59.6, we get minus, oh, I'm still using the highlighter, negative 1.3. 58.8 minus 59.6, negative 0.8. This one will be negative 0.5. This one will be 0.2. This one will be 0.8. And then that one is going to be 1.6. Okay, so that should be that column. Now, if we look at the pattern there, remember we talked about it goes from quite the largest negative, gets increasingly more positive, and then goes to the largest positive. So that all looks good as well. Right, last bit, x minus x bar squared. Remember, this column is where we don't have any negatives. So we're going to take all these values and we're going to square them into this column. So it's 1.3 times negative 1.3 squared. So it's negative 1.3 times negative 1.3 is 1.69. I've done it again. Keep writing in highlighter. 1.69. And then 0.8 times 0.8, or negative 0.8 times negative 0.8 is 0.64. This one will be 0.25. Then you have 0.2 times 0.2, which will give you 0.04. And then 0.8 times 0.8, which will give you 0.64. And then 1.6 times 1.6, which will give you 2.56. Okay. Remember, the sum of x minus x bar squared is the total of that column. All right, so we're just going to total that column up. So we've got 1.69 plus 0.64 plus 0.25 plus, plus 0.04 plus 0.64 plus 2.56. And for that we get 5.82. Okay, now the standard deviation calculation just across here to the right is going to be the square root. We do 5.82 and it's n minus 1. N is the sample size, the number of bits of data, so we had 6 bits of data, so n minus 1 must be 5. Remember to use your fraction button on your calculator, is probably the easiest way to do it. You put in the 5.82 and the 5 underneath your square root, and you should get 1.07. 1.078. Lots of 8s actually, so I'm going to round that to 1.08. And again, that's going to be in kilometers per hour. Now, were we asked to give it in a particular number of decimal places? No. So I'm going to stick with that 2 decimal places. I think that's reasonable. So that's what we're going to stick with there. Okay, so that's part A done. Both parts of part A done. Now the next part, this is the kind of new bit of the question. It says, make 2 comments comparing his top speeds on his 2 bikes here. And we're given the values of his old bikes here. Okay, so just to kind of isolate the data that I'm looking at, I'm going to write the new bike, and then I'm going to have the old bike over here, and I'm going to have the mean, and I'm going to have the standard deviation. And this is just a way for me to really just focus on the information that I need to answer question B. So on the old bike, top speed of 57.3, his mean top speed was 57.3, so that's 57.3 in there. And the standard deviation was 1.21. On the new bike, the mean that we calculated was 59.6. And the standard deviation that we've calculated is 1.08. Okay, so we're comparing these two sets of data, all right, which is fine. Let's just draw a line to separate those. Okay, now this is quite similar to what we did when we were comparing data previously. Think about it. We've been asked to make 2 comments, haven't we? Here it says make 2 comments. So we've got a mean, and we have a standard deviation and a standard deviation. So we're going to make a comment comparing the 2 means, and we're going to make a comment comparing the standard deviation. But we're actually going to change it up a little bit because we're into past paper territory and we're looking at standard deviation. We're actually not going to use the word mean. And so here we go for the first comment, comment 1. We're going to start by saying on average, because that's what we're dealing with. We're dealing with averages. What was this gentleman's name? Scott. On average, Scott achieved higher speeds on his new bike compared to his old bike. Okay, so just think about that for a second. Key phrase to start things off, say on average, okay? And what we're saying is we're comparing the speeds, okay? So Scott's achieved higher speeds and we're comparing his new bike to his old bike, okay? So I've said on average, I've said what I'm comparing, so I'm comparing speeds, and I've compared the 2 different situations, so the old bike and the new bike, okay? These are the key pointers on these types of questions. All right, so next question, standard deviation. Standard deviation, much like your interquartile range and so on, the smaller that value is, the less spread out your data is, okay? So the smaller your standard deviation, the more consistent it is. The larger your standard deviation, the less consistent it is, okay? And that tends to be the phrase that I want you to use. So, Scott start that again. On his new bike, Scott has achieved more consistent speeds. Now we can. Have a look here. We're comparing, I'm just going to add in actually more consistent speeds than he did on his old bike. So again, just look out for the key things here. All right, we're comparing the new bike and the old bike. We've said the words more consistent and we've talked about speeds, which is what we're comparing. Why have I said that it's more consistent? Because on the new bike, I've got a standard deviation of 1.08, and on the old bike, I've got a standard deviation of 1.21. So this value is smaller than this one. All right, so the data for the new bike is more consistent. It's less spread out because the standard deviation is smaller. Okay, so it's new bike and old bike, what we're comparing, and then it's more consistent and the speeds, okay? That is the important stuff, all right? Again, please take your time with this. Ask any questions that you feel you need to ask, okay? These things that I've highlighted are really what trigger the marks, okay? So I really want you to think about these statements. Once you will get good at these statements, okay? Initially, they're going to feel quite precise, quite prescribed, but you will get quite fluid with them because the questions are very, very similar every time. Okay, they don't really change that much. So get in touch with me if you have any questions with these. Watch the video back if you feel you need to, it's no problem. I'm around for you guys on Tuesdays and Thursdays, but you can ask me questions anytime. You just might get a slightly slower response, that's all. Okay, have a go at these. Easy marks in an exam is what we're looking for here. Good luck. Be in touch if you need help.